Hi and welcome to this video on similar triangles with Kirby Maths. So similar in maths means that things are an enlargement of one another, and we have this definition here that shapes are mathematically similar if the corresponding angles are the same and the corresponding sides are in the same ratio. So if we have a look at the angles first of all with this diagram, and here I've coloured in the angles in these triangles. You can clearly see that one triangle is larger than the other triangle, but the angles in a triangle add up to 180 degrees irrespective of the size of the triangle. So this angle sum is 180 degrees and this angle sum is also 180 degrees. So the green angle at the top here is the same as the green angle there. The orange angle is in the same position as the orange angle there and is equal to it. And finally the blue angle, the remaining angle, they are equal in those two triangles. So those two triangles are said to be mathematically similar, which means that one is an enlargement of the other. When we look at the sides of a triangle, I've used a right angled triangle so that I can keep all of my sides in the correct place. When we talk about corresponding sides, I'm talking about comparing the hypotenuse on these two right-angled triangles. So if I look at triangle A, which has got a hypotenuse of 5 centimetres, and I compare it to the hypotenuse in triangle B, which is 10 centimetres, I've had to multiply 5 by 2 to get to 10. Okay. I've also, if I look at this side here, which is next to the right angle and close to the hypotenuse, it's in the same position as this one. I go from 3 to 6, again I'm timesing that by 2, and the final side, this horizontal side, I'm going from 4 to 8 and I am timesing that by 2. So the scale factor as we move from triangle A to triangle B is 2. Now, in order to work out the scale factor, sometimes it won't always be nice numbers. We need to think about excuse me, how we are travelling from triangle A to triangle B, and it is always the side we are travelling to, or that our arrow points to, that we put on the top of a fraction, and the triangle we have come from that goes on the bottom of the fraction. And in this case I'm comparing the hypotenuse, so I'm making sure I'm comparing the corresponding sides, and this is 10 on the top of the fraction and 5 on the bottom of the fraction, and that cancels down to 2. It doesn't always cancel down to a whole number, an integer, but you can still use it even if it doesn't have a scale factor which is a whole number or an integer. So I'm going to do an example here where the numbers are really horrible. We've got two triangles here which we are told in the question they are mathematically similar, and we have the angles marked in. So we've got the angle with 2 arc marks on it here and the angle with 2 arc marks on it here. These two angles are equal. Now what's happened is they've also rotated this triangle round and flipped it over, so it's not helpful. So you need to make sure that when you're looking at similar triangles, you're looking at which angles are equal, and then you can work out the sides which you're going to use to find your scale factor. So here I want to find out what the side length A is, and in this triangle I've got one measurement, and that is opposite the angle which is marked with 2 lines. So here the angle which is marked with 2 lines, the number opposite it is the 8. So I'm going to use these two numbers, the 8 and the 6.4, and they are going to be my numbers I use for my scale factor. Okay, so I am going to go from this triangle to this triangle, and if I worked out my scale factor, it would be the number I was going to, 6.4 over 8. If I was doing this on a calculator paper, I wouldn't need to change anything in order to do that. Okay, I could just use this in my calculator. Now I need to think about I've got this angle here marked with one line, and it corresponds to this angle here. So the side, which I'm going to use to find A is opposite the single marked angle, and 7 is opposite the single marked angle. So to work out what A is going to be my scale factor, which is 6.4 over 8. I'll just do this on my calculator, and I'm going to times it by 7. Okay, if I do that on my calculator, 6.4 over 8 times by 7 gives me an answer of 5.6. I need to check whether that sounds right or not. So I'm looking at my triangle here. So I'm going from this triangle 8 to 6.4. This length is getting less. So if I'm going from this side 7 to the A, that's also going to get less. This triangle is smaller than this triangle, and 5.6 is indeed smaller than 7. I could also work out B if I've got enough room on the bottom here. So I could use my scale factor, 6.4 over 8. Obviously, if that works out to be a whole number, then just use the whole number. And this time I'm going to use the other side, the 6. That's opposite the 3 marked angle. So that's the B opposite the 3 marked angle, and the 6. Times that by 6. So on the calculator again, 6.4 divided by 8 times 6, and that gives an answer of 4.8. Okay, so just to reiterate, it's really important that you are using the sides in the correct place, and it's useful to consider where they are in relation to the other angles to help you work out if you're using the correct sides or not. Thanks for watching.